able to see the presentation, let me know, okay? Okay, we are continuing with the production function that we have already started last lecture that didn't do properly. This is the second part of this presentation. Okay, let me make this. As I have mentioned to you, up to now we are exercising the consumer function, and now last lecture and today we are presenting the production, which is the supply side of the economics. But unfortunately, we are not able to enlarge and increase this up to the end of these chapters where we are going to the monopoly markets either, because we have restricted time this semester. Therefore, I will stop end of this chapter for your final exam. This is the last lecture and chapter. The supply process, as you are understanding, is the production, is representing the production function, and is of course concentrated to the factors of production where we are heavily responsible for creating surplus production, goods and services in a given period of time, where we are increasing and enlarging this GDP, so-called this uh, growth rate. Production is the name given that the transformation of factors into the production, therefore into the goods or production. It is therefore very important because we are using the available resources and of course factors of production for increasing and enlarging the goods and services in the given market. The firm is in a process where we are concentrating to accelerate and of course increase this productivity in the factors of production and into the consumer good, where we are able to sell and buy in the markets. Of course, firm organizes factors of production. It is the responsible, let's say, intermediary or institution, where the people who are holding their hands the factors of production, so-called labor, land, technology, available resources, everything, and capital, then this will be, of course, meet with the entrepreneur and put into the process and create some reasonable goods and services in this direction. The production, of course, is very important. As I said to you, without any production, we are exercising scarcity and we are exercising too much problem, crisis, and economical difficulties in our countries. Therefore, producing and, of course, becoming productive is very important in this direction. Firms and the markets are the important part of the economy. They are producing and directing their production and, of course, the services towards the markets. And we, as a owner of the factors of production, going to join to this market for being able to consume this produced goods and services. Therefore, we are on the one side holder or owner of the factors of production, and on the other side, we are, of course, the household owner, where we are able to buy these goods and services. Role of the firm in the supply process: people offer the factors of production in such a direction where the land, labor, capital introduce and, of course, create effectively to the market. Firm transform the factors of production into the, of course, goods and services, and of course offer to the consumers as much as possible in a reasonable prices. Production is the transformation of the factors into the goods and services. Therefore, it is important, as I mentioned to you, and ultimately all supply comes from individuals, because controls the factors of production depends to this household owner. Firm is an economic institution that transforms factors of production into the goods and services. Firms organize factors of production. Firms produce goods and services, and firms sell produce goods and services towards to the market where the consumers are ready to buy in a reasonable prices. A mutual firm organizes production and subcontract out or work. Many of the organizational structure of the business are being separated from the production process. The role of the firm is, of course, very important in this direction. A mutual firm only organizes the production. As I mentioned to you, it is very important part of the production operation process. Mutual firms subcontract out of workers, and of course, more and more of the organizational structure of business is being separated from these businesses. When we are looking to this equation for the firm, where we are concentrating to total cost and total revenue, we are understanding how it is going to be, of course, effectively created for being able to enlarge and increase the economy. Because production operation process is profit oriented. Firms are not the non-profit organization, they are the profit organizations. Therefore, they are using their reasonable resources as much as possible in a lower level of cost to produce reasonable goods and services for receiving or obtaining some revenue. And when we are looking to this equation, we are understanding the differences between total revenue to total cost will give the profit to the firm. Of course, part of this profit is distributed to the government as a tax, and as a sum of the profit is, of course, flashback again to the production operation process as a wages, as an interest rate, as a capital. Therefore, it is important. When we look to this equation, we are observing total revenue is the amount of the total produced goods multiplied with the price of these goods. And of course, total cost is the amount of the labor which is going to be in the production operation process, will be multiplied with the wages, plus the R is, of course, indicating the real interest rate, so-called the interest rate, not the nominal. And the K is the capital, which is going to be used in the production operation process. And the difference between this total revenue and total cost will give us the profit. For economists, total cost is explicit payments to the factors of production plus the opportunity cost of the factors provided by the owner of the firms. For the economist, total revenue is the amount of the firm received for selling its product or services, plus any increase in the value of the assets owned by the firms. Due to this reason, the difference between this will give the firm the spaces for enlarging and increasing their production and, of course, the market as much as possible. We have here a simplest example. The wage is supposed to be is $10 per hour, and the rent is air is, of course, $20 per hour. The solution when we are having this, then of course for finding the total cost is $1,000 is all the combination which is given between labor and capital is then of course will be then put into the equation. 10 plus labor plus 20 plus capital is equal to 1,000. Therefore, capital equation will be then of course 50 minus 0.5 labor, which is then of course representing this cost, total cost of the production operation process. Suppose a firm needs 10 workers and 1 machine. Another example I'm going to give you. Produce a single unit. What is the production function? Here we are asking then, of course, the other part of the equation. The wage is supposed to be 5. The rent is again the real interest rate is of course 100. What is the cost of producing 50 units? What is the cost of production, function or cost function? The solution, of course, again, since F is, of course, is the function of labor and capital, then of course is expected to be minimized in 0.1, which is the given example, the labor will be labor and capital. To produce 50 units, we need 50 machines and 500 workers. and the total cost will be then of course 500 multiplied 5 and 50 plus 50 plus 50 multiplied 100 will be then 7,500. Then labor will be then equal to 10q, and q or capital will be equal to then q, which is going to be produced. Then total cost will be then of course W or wages multiplied with the labor in the, of course, function of production, and capital, again, the real interest rate will be the function of the production. Therefore, 5 times 10 of this production plus 100 times this produced goods will be then equal to 150Q. This will be then, of course, production or total cost production, which is expected to be solved in this example. When we are going further for looking out to this profit, for being able to understand how it is going to be maximized in a given scenario, economists and accountants measure the profit differently. Accountants focus on the explicit costs and revenues, and explicit costs, as you are understanding, are out-of-pocket costs, that is payments that are actually made, wages that a firm pay its employees, and rent that the firm pay for its office as an explicit cost. An implicit cost, opportunity cost of resources already owned by the firm and used in businesses. For example, expanding a factory onto land already owned. Accounting profit is equal to the explicit revenue minus explicit cost. Therefore, the economists focus on both explicit and implicit costs together for the revenue. The economist's profit is then, of course, will be then represented with the explicit and implicit cost together, which is going to be subtracted from the explicit and implicit cost together. Therefore, the production cost or production process is the, of course, dependent to this period of time where we are going to use in the production operation process. Either it is going to be short run or in the long run. In the short run, we are understanding that a firm is constrained or is concentrated to, of course, production decision or production operation process, and it can make some inputs which are fixed. And in the long run, a firm choose from all possible production technique, all inputs available, which is going to be changed, and of course, dependent to the time, is variable. The term long run and of course short run do not necessarily refer to a specific period of time, but to the flexibility the firm has in changing the level of output. Therefore, long run and short run is totally different application in the economics. Short run, where one factor of production is supposed to be fixed, that of course dependent to the time period, and fewer than 6 months or of course to 1 year is expected. The short run is generally defined as the time horizon over which the wages and price of the goods or inputs produced are sticky or inflexible in a given period of time, which is sticky means then of course is a fixed, not change. Very long run, then of course, where all factors of production are variable, which means it's not fixed, it's flexible, and the additional factors outside the control of the firm can change. Technology, governmental policies, the price of the wages or price of the capital is going to be changed in this given period of time. The long run is defined as the period of time over which these inputs have time to adjust. Therefore, it is, of course, requires some long run process. More specifically, in microeconomics, there are no fixed factors of production in the long run, and there is enough time for adjustment so that there are no constraints preventing changing the output level by changing the capital stock or by entering or leaving an industry. Therefore, in the microeconomics, supposed to be everything is estimated regarding to these factors of production which is given, therefore is fixed. In economics, in the long run is a theoretically concept in which all markets are in equilibrium and all prices and quantities heavily fully adjusted and are in equilibrium. Therefore, this is of course supposed to be is in changing. This contrasts with the short run, where some factors are variable, depend on the quantity produced, and others are fixed, paid once, constraining entry or exit from the industry. And the long run contrasts with the short run, in which there are some constraints and markets are not fully in equilibrium. Therefore, some variables are expected to be adapted and or change towards this political, of course, application in the time period where it is heavily affecting and changing the market, because in the long run, especially the inflation, the price changes affecting and moving all together, all the variables and changing. Due to this reason, we are not able to fix it in the long run. The production tables and production function, of course, is very important in this direction. Firms combining factors of production to produce goods and services. And production table, as you are understanding, is the table showing the output resulting from various combination of factors of production and inputs. And real world production tables are complicated. It's not like it is as it is given. This analysis will concentrate on short-run production when in which one of the factors is fixed. Due to this, in the short run, is of course always is expected that some variables is fixed. Production tables and production function shows the output resulting from various combination of factors or production or inputs in a given period of time. And the of course marginal product is the additional output that will forthcoming from an additional worker or inputs remaining constant. An average product or average product, which is going to be used in the production operation process, is abbreviated as AP, is found by dividing the total product by the quantity of the variable input. Therefore, the average product is the total production divided to the labor or capital is supposed to be estimated. And of course, when we are looking to the production table and the production function, you are observing in the upper level the total production, and the lower level of this table, the marginal product and average product together. As you are observing here on the table, the production function is a curve that describes the relationship between the inputs, factors of production, and the outputs. And as you are observing here, output is on the vertical line, is in the y-axis, and the x-axis is the unit of labor or unit of capital can be here. We are using the labor, and we are trying to analyze the total production, and of course the average production and marginal production. When we are looking to this total production, as you are understanding and observing, as much as you are increasing the labor, every next level of this labor that you are adding to the production operation process is reducing amount of increase creating in the production operation process. Due to this reason, we are heavily dependent to this labor productivity. As much as the productivity is not, let's say, increasing function of this production, then we have to determine the level of production which is going to be the best possible option in a given scenario. When we are looking to the down lower part of this graphic, you are observing that the marginal product is intersect the average product curve from the top, from the optimal level. And the marginal products, of course, the optimal level is the level where the production and of course the productivity is the highest level in the total production operation process, as you are observing, because the first starting level of this production is usually the highest level. As I mentioned to you, the first unit of the production and the contribution of the input to the production is 1 to 1, therefore is the 1. And the second unit's production is always the half of it is 0.5. And the third unit's production or the contribution of the input or the labor to the production operation process is 0.33. And the third to fourth unit of the product or the produced product to the production operation process is 0.25. And the fifth unit production and the, of course, labor or the input contribution or the productivity to the production operation process is of course 1/5, which is 0.20, and it goes, as you are understanding, decreasing amount of increase in this direction. Due to this reason, the marginal product is supposed to be highest level when the inputs contribution started, and of course, and the average level of this is dependent where it is intersect the marginal product it's from the top level or the optimal level. And as you are observing, total production is going up and up, but it is decreasing amount of increase. This is then the diminishing returns of input or the labor or capital. This is then productivity or marginal product. Therefore, as much as we are increasing our production, our, let's say, profit and our returns is decreasing amount, increase where the total production is reaching to the top level, to the highest level. And then after this top or optimal level, you are observing marginal product is intersect to the x-axis and becoming to the 0 point, where the optimal and positive contribution to this production operation process is then of course become 0. And after this position or point, then we are having negative or decreasing amount of contribution to the total production operation process. Therefore, at the top level or optimal level of the production, we are understanding there is no need to enlarge and increase our capacity or our production operation process. Most of the firms are trying to become and enlarge their production operation process without controlling and of course evaluating this. And then of course mostly small medium-sized enterprises in 2 years or in 5 years they are uh, becoming bankrupt and disappear from the market. The production table here is also given to show you how it is going to affect and change the market. The production function tells the maximum amount of output that can be derived from a given number of inputs. Optimal input usage rule: one input case when price of product is $2 and labor is supposed to be $10. The marginal revenue is calculated by dividing the change in the total revenue by the change in the quantity sold. As you are observing here, the labor unit is given 1, 2, 3, 4, which is unique. 5, 6, 7 is unique, and total product is given here 10, 25, 45, 60, 70, 75, and 78. It goes like this. As you are observing, as much as you are increasing the total so-called amount of the labor, the contribution of this is not as it is expected. As you are observing, in the first places, it is 10 to 25, which is considerably high, and then from 25 to 45, and then 45 to 60, you are observing there is a small amount of decrease, but it is increasing amount. It is decreasing amount of increase realized in this total products. Therefore, it goes like in this direction. It is of course realized very steadily decrease to 45 to 60, 60 to 7. As you are observing, there is differences among the first is 15 from the marginal product when we are observing. Then from 25 to 45 is 20. From 45 to 60 is 15. From 60 to 70, 10. From 70 to 75 is 5. From 75 to 78, 3. You are observing marginal product and productivity is decreasing, and at the end it goes 0 and then is going to negative, which is not illustrated in this graphic. And the total revenue, when you are calculating, the total revenue here is then of course P multiplied Q, and P multiplied, and P is here given is 2. Then you are multiplying the product with this, which is total product is 10. 10 times 2 is 20. 25 times 2 is 50. 45 times 2 is 90, because total price of the product is given $2. Then you are multiplying 60 times 2 is 120. 70 times 2 140. It goes like this, and 75 multiplied 2 is 150. It goes like this. The marginal revenue product, then of course, as I mentioned to you, is multiplied with wages to differences between the labor. Then 20 is given here, as you are observing the difference between this. Then of course wages multiplied with, then of course here is then 20, and then it goes to 40, and then it goes to 30, and then to 20, then 10, 6, and 4. It's also decreasing. And total labor cost is again here. Total labor cost is illustrated here, multiplied with the quantity with the wages, and it was 10 to 20, then 30, and then 40, and then 50 to 60, and it goes like this. And marginal labor cost then is of course unique again, because the difference between the labor is 1, every difference is 1, then multiplied with 10, then is of course 10, 10, 10, 10. It goes like this. This is then of course the simplest estimation of the production operation process regarding to his cost and benefit analysis. And when we are looking to this table, we have another example. The total output is again here given 0, 4, 10, 17, 23. And here is, of course, again, unique increase of the labor, 1, 2, 3, 4, 5. And the marginal product is again 4, 6, 7 differences between the total output. And the average product, of course, total production divided to the labor, which is 1 again. Then dividing this 4 to 1 is going to be 1, and then is going to be 6 is divided then again 5. Then of course when you are dividing this to labor again is 5.7. Then it goes like this: 2, 5, 6, 5, 2, 4, 6, 4, 0, and 3, 3. And then it goes to 2.5. And when we are looking to this production function, and again this marginal revenue and average revenue, you are understanding in the first phases we are having the increasing. In this second phases we are having again the, of course, decreasing amount of increase, and the third phase we are having the negative or the decreasing level of production operation process in a given scenario, which we have exercised this in the former class. And as I mentioned to you, where the first phases realize the highest marginal productivity observed, and where marginal productivity or marginal product is intersect the average product in the top level, optimal level, there is of course optimal intersection of the optimal production in a given scenario, where it is decreasing to the 0, and at 0 marginal productivity is of course 0, where the optimal production in the given total production curve is realized. And after this, as you are observing, the belly shaped figure is turning back, and of course then it is negative, it's turned to negative. Then marginal productivity and marginal productivity for labor and marginal productivity for capital is then of course two important factors which is going to be used in the production operation process. The marginal product of labor is the rate at which total output changes as the quantity of labor the firm uses in change. And the marginal product of capital is the rate at which total output changes as the quantity of capital the firm uses change. Therefore, marginal productivity to labor is delta Q over delta L, and marginal productivity, it should be K here. I didn't change it. It should be K, sorry. It should be K, because we are talking about the capital. And then it's, of course, delta Q over delta K. And when we are looking to this marginal productivity, we are understanding that this is the most important part of the production, because this is giving us reasonable information about the productivity, which is very important in the production operation process. We have here one example, the isoquant example, so-called. The isoquant curve, first I have to give you, as you are observing, is a curve that shows all the combination of labor and capital that can produce in a given level of output. As you observe here, this is totally dissimilar with the indifference curve, but here we are using the input, the capital and labor, and the capital, as much as you are increasing labor, it is becoming labor intensive, and as much as you are increasing the capital, it is becoming capital intensive. And here it is dependent to you where you are going to fix your production operation process, where your budget line is intersect and of course become tangent to this isoquant curve. And here at point A, we have capital intensive, very capital intensive, and point D, we have labor intensive. As you are observing, we are using 9 units of labor and 5 units of, 9 units of capital and 5 units of labor. And when we are looking to the D, we are using 20 units or 20 person as a labor capacity, and 3 units of capital for producing any X product. Therefore, this is totally dependent to the diversification of production operation process. Either you are going to use capital intensive or you are going to use labor intensive. If you are using, for example, automobile, you need probably more capital intensive. And if you are using some textile or some other, let's say, agricultural production, you probably use more labor intensive production operation process in this direction. In a given example here, we have the Q as a production function, which is dependent to the labor and capital. And of course, 0.1 labor capital plus 3 labor power of 2 capital minus 0.1 labor power of 3 to capital is given. Then we are assuming that capital is, of course, 10, so that the function becomes labor to 10. Of course, then we are replacing this k with 10. Then we are having 0.1 L multiplied with 10 plus 3 L power of 2 multiplied with 10, and of course minus 0.1 L power of 3 is going to be multiplied with 10 is going to be L plus 30 L square is becoming minus L power of 3. Of course, marginal productivity of labor is then, of course, delta Q over delta L. Then this is, of course, when you are getting the derivation of this regarding to the labor, is 1 plus 60 L minus 3 L square. And where does marginal productivity labor reach a maximum? Then, of course, D in bracket 1 plus 60 plus 3 L power of 2 is closed bracket divided to the delta L is then, of course, 60 plus the 6L is equal to 0. Then 60 equal to 6L is given. Then L is supposed to be 10 for a given example. The isoquant curve I have already explained to you. The linear isoquant curve is given in this direction if it is a vertically, or if it is a linear curve, intersect capital and labor, not nonlinear, which is given in the former example. The curve shows the perfect substitutability or substitutability between the factors of production. This means that any quantity can be produced either employing only capital or labor, or through n number of combination between these two. The perfect substitute in production input in a production function with a constant marginal rate of technical substitution. Therefore, Q is equal to A multiplied with labor plus B multiplied with K. This is a linear production function which is perfectly substitute each other. The fixed proportion production function, a production function where the inputs must be combined in a constant ratio to one another, isoquant for the production of water, where the inputs are atoms of hydrogen and atoms of oxygen is 0, since each molecule of water consists of 2 hydrogen atoms and 1 oxygen atoms. Then the input must be combined in that fixed proportion. Therefore, fixed proportion cannot be changed. It is not possible to substitute to each other. This is perfectly complement in production inputs in a fixed proportion production function, which is the hydrogen and, of course, oxygen is joining into the production operation process in a given scenario. The right angle isoquant curve is given here, where this is one of the types of isoquant curve where they are strictly complementary with no substitution between the factors of production. According to this, there is only method of production to produce any one commodity. This curve is also known as Leontief isoquant. Input-output isoquant is the right angle curve, and Leontief paradox, as I mentioned to you, is mostly dependent to the labor intensive, where you are using in the production operation process with the capital intensive production, where the people are becoming very, very, of course, expert and, of course, know-how person and using their technology. This is exercised in the United States, and of course in the 60s, this was assumed to be in the United States, the production operation process realized in the capital intensive. Unfortunately, after this Leontief paradox and Leontief example or exercise or research realized or study done, they observed there is more labor intensive, because at that time even they use more capital with labor, because for using this capital they are using more of course know-how, which is dependent to the labor capacity. And this is then of course very contradiction to the economics, where they are using more capital intensive and not labor intensive is supposed to be, is of course not always valid. Here we are having, unfortunately, this graphic is not very well illustrated because it was not very clear, but I want to show you again this isoquant curves, where the economic regions illustrated with the white colors, white area, and the uneconomic regions or areas illustrates the, of course, non-profit or diseconomic uh, areas. Isoquants, of course, the backward bending in the both side and upward bending of these colored areas is not economically acceptable or profitable areas. And as you are understanding from this curve, the isoquant curve mustn't be backward or upward bending or sloping for the economical, of course, profitability. When you are looking any isoquant curve, you have to see this, of course, um, uh, let's say, convex position to the origin, but not uh, upward or backward bending shape at the end of these curves. It should be somehow realized in this direction, where it is more convex to the origin and somehow become parallel each other. And when we are looking to this table, the workers is given here total output, which is given to you again. We are going to flashback again to see the marginal product and average product here. Again, the average product is the output per worker. Therefore, we are having here again this similar example. Then you have here, when you divided this 10 to 2 is 5, 17 to 3, 5, 3, 5.7, 23 to 4 is going to 5.8. Therefore, marginal product is the differences between these two. And the average product, as I mentioned to you, for my example, is dividing total output to workers, then is expected and of course realized. And as you are observing here, we are having here the marginal product at 0.8 to 7 or 7 to 8, where it is the optimal production. And after this, you are observing 7 and 8 is 32. And then after ninth or 10th workers joining to this production operation process, the marginal productivity turned to negative. Therefore, it is expected that the, of course, maximum capacity of this market, of this firm, should be limited with 7 workers. And of course, after this, negativity is expected. As you are observing and understanding here, the average product here is increasing up to the 5th, and then after then is going to negative to 5, 6, 5, 2, 4, 6, 4, 0, 3, 3, and 2, 2. Therefore, you have to determine where you are going to stop. If you are not able to stop, where you are finding your, let's say, business profitable, then you will insist to enlarge and increase and become more, of course, competitive in the market. You will lose, because as you are observing in this direction, this shows that every firm cannot enlarge their businesses as much as they wish, because they will, of course, become negative profit. They will lose their profit share and, of course, market share, and then, of course, not able to survive in the long run. In this direction, we can suggest to create holdings or group of holdings with different companies, small, medium-sized companies, being able to become more competitive. Because in the economics is also very popular, don't put all the eggs in the same basket, because if the basket is not well fixed, then you will lose your all eggs. Therefore, in the production operation process, you have to do this analysis continuously for being able to understand where you are going to go and where you are going to enlarge your businesses as much as possible as it can be. The law of diminishing marginal productivity, both marginal and average productivities initially increase, but eventually they both decreases. The marginal productivity to labor is delta Q over delta N, and marginal productivity to capital is delta Q over delta K. Therefore, increasing marginal return to labor, the region along the total product function where output rises with additional labor at an increasing rate, and diminishing marginal returns to labor, the region along the total product function in which output rises with additional labor but at a decreasing rate. An average product of labor, the average amount of output per unit of labor is then of course total Q over L, where Q over L is then of course enough to estimate. Then when we are looking again to this curve for being able to understand all together, you observe again the irrational region where the elasticity is higher than 1, as I mentioned to you. The rational where the elasticity is between 0 and 1, and irrational where the elasticity is, of course, less than 0. If it is higher, the one is inelastic. If it is between elastic, and therefore you have to determine where you are going to stop. And it is better to realize your production operation process where you are having the elasticity between 0 to 1. Then this will then of course create a sustainable moment, and of course sustainable model, and of course sustainable development to your businesses if you are continuously controlling and of course inspecting your production operation process, whether you are in the good direction or not. And as you are observing here, again we are illustrating where it is intersect the 0, the marginal productivity, it reaches to the highest level, the total production. Therefore, increasing yield is realized where the highly increasing yield where it is realized up to the elasticity where it is 1, and then after this then it goes to be between 1 and 0 where it is decreasing but it is rational, and after then elasticity 0 it goes to negative where it is not desirable, not of course rational for the producers. Due to this reason we have to determine the of course best possible let's say production capacity for our company regarding to our market structure. When average product is increasing sorry, in labor, marginal product is greater than average product. That is, if average production to labor increases in labor, then the marginal productivity to labor is higher than average product to labor. When average product is decreasing in labor, marginal product is less than average product. That is, if average product to labor decreases in labor, then the marginal productivity to labor is decreasing then of course or less than average product to labor. When average product neither increases nor decreases in labor, because we are at a point at which average product to labor is at maximum, then marginal product is equal to average product, and of course marginal product to labor is equal to average product to labor, as it is illustrated in the graphic. Then after this, and of course, as I said to you, you are starting to decreasing amount of increase in the economy. The law of diminishing marginal productivity, the means, of course, initially the production function exhibits increasing marginal productivity, which is the delta marginal productivity of labor or to labor is equal to delta Q over delta L, or the marginal productivity capital is delta Q over delta K. Then if we are supposing that it is exhibits diminishing marginal productivity, and finally it exhibits negative marginal productivity in a given scenario. The marginal law of diminishing marginal productivity, the most relevant part of the production function, is that part exhibiting diminishing marginal productivity. And marginal productivity labor is equal to delta Q over delta N, and marginal productivity capital is delta Q over delta K. Then the law of diminishing marginal productivity is then, of course, as more and more of the variable input is added to an existing fixed input, after some points, the additional output one gets from the additional input falls. Therefore, this is then, of course, the reason why we are continuously inspecting our production operation process where the marginal productivity becomes negative or becomes 0. Then we have to stop our production operation process in a given scenario. Again, here is illustrated this. and mentioned once again, increasing level is stopped where the average product is 5.8 and diminishing is going to be after 5.8 to 4 somehow, and it goes to diminishing absolute where it is going to after this to the negative. And as you are observing, after this 0, marginal productivity is diminishing, and after the average product is 5.7 is diminishing marginal returns, and after the marginal product is 0, the diminishing absolute return, because it goes to negative in a given scenario. It should be negative here, but it's not illustrated. This 2 and 5 in the marginal product should be negative, which we had done here before. As you see, it was negative. Okay. Then again here, the increasing marginal returns illustrated, diminishing marginal returns illustrated, where it is intersect the average product, and diminishing returns or absolute returns where the marginal productivity is in the 0. This is then, of course, increasing marginal productivity is going up to the first level or first phases of the production operation process, and diminishing marginal returns where it goes to the optimal level or highest maximum level of the total production, and diminishing absolute productivity where the production function is turned to the negative. And in this direction, increasing marginal productivity again is realized where the marginal productivity reaches to the maximum level and intersect the diminishing marginal productivity and goes to the 0. Diminishing marginal productivity goes up and until 0 is continuously realizing these downward movements. And then, of course, after intersecting this 0 point, then diminishing absolute productivity is realized. Once again here, this differences is illustrated in this given scenario. And this is then, of course, illustrating again increasing marginal productivity, diminishing marginal productivity, and of course, diminishing absolute productivity, which is certainly illustrated here. As you observe here, where it is going to 5.7, then it goes to until 4.6 is become to 4 is becoming to the decreasing or diminishing marginal productivity, and increasing realize where this the marginal productivity becomes the highest position at 7, and then after this it goes to 0 where the diminishing marginal productivity realize, and where it turns to max negative after 0. And of course, you are observing here the average product is also turns to the decreasing level heavily observed in a given scenario. Therefore, marginal productivity after reaching to the highest level is, of course, the increasing marginal productivity stop. And then after this top level of this, we are exercising marginal diminishing returns. And then after 0, where you are observing here, it goes to the negative, where it is the absolute productivity diminishing realized. The law of diminishing marginal productivity, if it didn't hold through, the world's entire food supply could be grown in a single flow approach, as I mentioned to you, which is not realized as you are understanding. And diminishing marginal rate of technical substitution, a future of production function in which the marginal rate of technical substitution of labor for capital diminishes as the quantity of labor increases along the isoquant curve. And marginal rate of technical substitution is equal to marginal productivity to labor divided to marginal productivity capital is equal to delta Q over delta L, and divided to delta Q over delta K, and this is then, of course, delta K over delta L, which is, of course, marginal productivity labor to marginal productivity to labor dividing to marginal productivity capital is equal to delta K over delta L, which is, the, of course, derivation of this two together in a given scenario, which is the differences between this capital and labor is introduced to you. The elasticity of substitution is, of course, becoming very important problem in this given scenario. A measure of how easy it is for a firm to substitute labor to capital is becoming question. Therefore, it is equal to the percentage change in the capital to labor ratio for every percentage change in the marginal rate of technical substitution of labor for capital as we move along an isoquant curve. The elasticity of substitution measures the percentage change in the capital labor ratio for each 1% change in the marginal rate of technical substitution labor to capital as you move along the isoquant curve. Therefore, Q in the Cobb-Douglas equation is supposed to be labor power of 0.5 and capital is 0.25. Therefore, marginal rate of technical substitution labor to capital is marginal productivity to labor to marginal productivity to capital will give us the substitution of the elasticity. The elasticity of substitution between inputs can be then illustrated with this, which is illustrated here. You are observing here, this is sigma is equal to percentage change in the capital to labor will be divided to the marginal rate of technical substitution percentages, and delta, this is then of course delta K over L divided to KL, and divided to delta marginal rate of technical substitution divided to marginal rate of technical substitution is equal to delta linear or logarithm K over L divided to D ln marginal rate of technical substitution. Inputs are perfectly substituted if sigma is in infinitive. Inputs are perfectly complements if sigma is equal to 0. And lower sigma means it is harder to substitute K for L and vice versa. Therefore, if it is sigma value is low, then substitution is of course also very difficult. And higher sigma means it is easier to substitute K to L. Vice versa is also realized. Then of course we have to note that sigma is units free. Calculating elasticity of substitution example, consider a production function whose equation is given by the formula Q in root square capital to labor, which has corresponding marginal productivity labor 1 over 2 0.5 root square capital over L, and marginal productivity capital is of course 0.5 root square L over K. Show the elasticity of substitution for this production function is exactly equal to 1, no matter what values of K and L are. Therefore, we are going to analyze then, of course, this given scenario, which is the sigma question in this former slide. The solution, marginal rate of technical substitution is equal to marginal rate of technical substitution labor to capital is equal to marginal productivity to labor divided to marginal productivity capital, and marginal productivity labor to marginal productivity capital is then of course, if we are going to get this derivation, 1 over 2 root square K over L and 1 over 2 root square L over K, and simplify it to, of course, with the sigma indicates of course percentage change in the K over L dividing to the percentage change in the marginal rate of technical substitution differences labor to capital. Since marginal rate of technical substitution labor to capital is equal to K over L, it follows as a percentage. Since using this definition of the elasticity of substitution, it follows that diminishing or differences, or let's say the marginal rate of technical substitution labor to capital, which is of course the differences between marginal rate of technical substitution for marginal productivity labor to marginal productivity capital, the differences so-called, will be the exactly, of course, to percentage change in delta or differences K to L or K over L. This means diminishing or differences marginal rate of technical substitution labor to capital is equal to the capital labor ratio, which is then of course K over L, and then of course differences between or percentage change in the marginal rate of technical substitution labor to capital is equal to the percentage change in the capital to labor. And Cobb-Douglas production function of the form Q is equal to A L power of alpha K power of beta, where Q is the quantity of labor from L units of labor and K units of capital, and where A alpha and beta are positive constants. Return to Scala, the concept of this tell us that the percentage which output will increase when all inputs are increased by a given percentage. Return to Scala, of course, is the change or the percentage change in the quantity of output, and of course percentage change in the quantity of input is supposed to be divided and of course realized. And if alpha plus beta is higher than 1, is increasing returns to scala a proportional or proportionally increases in all input quantities, resulting in a greater than proportionally increase in the output. Alpha beta, total alpha plus beta, if it is less than 1, decreasing return to scale, a proportionate increase in all input quantities, resulting in a less than proportionate increase in output. And alpha plus beta, if it is equal, constant return to scale, a proportionate increase in all input quantities simultaneously, that results in the same percentage increase in the output. Therefore, if we are giving this another example for being able to understand this impact of this alpha and beta, which is going to be affecting and changing the economy, the problem, does a Cobb-Douglas production function exhibits increasing, decreasing, or constant return to scale? Illustrate this or show that it is not like this, or if it is like this. Solution: let's suppose L1 and LK1 denotes the initial quantities of labor and capital, and let Q1 denotes the initial output. So quantity is equal to A L power of alpha power of K power of beta. Now let's increase all input quantities by the same proportional amount with lambda, where lambda is supposed to be one is a coefficient here, is a intercept, where is higher than 1, and let's Q2 denotes the resulting volume of output. Q2 then is of course equal to A lambda labor 1 is power of alpha, and lambda K or capital 1 power of K. Therefore, lambda A plus B, we can sum these lambdas together. L1 power of alpha and K power of beta is equal to then alpha lambda, power of alpha plus beta multiplied with Q1, because the equation which is given here will gives us, or will summarize with this first equation which is given here. Therefore, Cobb-Douglas return to scale can be can be then summarized as alpha plus beta. If it is higher than 1, then lambda power of alpha plus beta is higher than lambda, and so Q2 is higher than lambda Q1, increasing return to scale. And alpha plus beta, if it is less than 1, then the lambda power of alpha plus beta less than lambda, then so-called the Q2 is less than Q1 lambda. Decreasing return to scale again is realized, and alpha plus beta is equal. If you put the numbers here, you will see after this class, alpha plus beta is equal to 1, then the lambda alpha plus beta equal to lambda, then so-called the Q2 is equal to lambda Q1, constant return to scale. Therefore, Cobb-Douglas return to scale shows that the sum of exponents alpha plus beta in the Cobb-Douglas equation or production function determines whether returns to scale are increasing, constant, or decreasing. For this reason, economists have paid considerable attention to estimating this sum when studying production functions in specific industries. Due to this reason, this let's say equations and proportions between this alpha and beta, which should be equal to 1 or less than 1, is giving us information, or higher than 1 is giving us information about the economical intersection or inclination, whether it is going to increase or decrease or is constant. This is then of course our lecture for today. If you have any question, you ask me. If not, then I will finish. If you have any question, because this is our last lecture. If you don't have any question, then I will finish it.
Doctor, I want to ask a question concerning the final exam.
Yes. It will be.
How is it going to be?
It will be multiple choice again, because I don't have any other option. When I put these problems with the numbers, you are not able to put the correct format for answering the equations. Therefore, I am not able to understand what you are doing. You understand? Therefore, only writing the numbers is not helping you because you are writing some different numbers, or you are writing, for example, x equal to 0.10, which is going to be written probably only 0.10. And if you write x equal to
Yeah.
0.10 into the answer sheet, then this will become as a wrong or mistake, is accepted by the system as a mistake. Therefore, I prefer only to put all the multiple choice exams, which is giving you the answers, or maybe some fill in the blanks, some
Yes.
papers, and maybe some one or two example with this numbers. Then I will control, because if the all questions with numbering and of course calculating, this will be more difficult for you, and more difficult for me to follow up what you did. Therefore, I will try to do as much as possible multiple choice exam, around 30
Thank
questions
you so
maybe,
much,
or
sir.
something like this. I try to do my best for you. I hope you will profit it.
Okay.
If you don't have any question, then
Yes.
we will see each other next week with the exam. Okay, you just come to this
Okay.
again
Thank you,
online.
doctor.
I will take your attendance, and then you will join to this
Okay.
exam. If you don't have camera, is not problem. You will do the exam online and send, of course, automatically the system sent me the results. Okay. If you don't have any question, then
Okay. Thank you so much.
see you then next week. Okay, thank you. Bye bye.
Okay. See you.
Bye
Thank you.
bye.